We're going to go through the AP Physics 1 midterm review sheet. So we start with problem number 1. We read through and it says a 20 kilogram object is moving to the right. The graph below shows the speed of the object over a 50-second period of time. So a speed versus time graph, a couple things we got to remember about it. First, we got to remember that the slope is acceleration. And it's helpful to remember that Um, the area under it is the displacement of the object. Positive areas will be forward displacement, negative areas will be backwards displacement. So question A asks to calculate the acceleration during the first 10-second interval. So like we said, since acceleration is a change in velocity over time, on this graph, um, velocity or speed, both represented by v. The slope, which is delta y over delta x, well, y is velocity and x is time. So slope is that. So the first 10 seconds, we go from 0, 0 to 10, 15. And so what's the slope of that? Well, change in y is a positive 15 meters per second. And the time it took was 10 seconds. And that means our acceleration is 1.5 meters per second squared. All right, what else? Calculate the acceleration between 30 and 50. Same process, just looking at the slope. But now our slope is going to be a negative change in the y, right? We've gone down 25, so that's a negative 25 meters per second. And how long did that take? Let's see, it took a total of 20 seconds. So we take 25 divided by 20, we get 1.25, and that's a negative meters per second squared. There's our acceleration. All right, net force acting on the object during that same time interval is B. So net force, we're going to remember that force equals ma. And since they gave us the mass, right, this was a 20 kilogram object. And now we have our acceleration from the previous part, meters per second squared. We take that answer, multiply it by 20, we get 25. So this is 25 or negative 25 newtons. And that negative just means that the force is in the opposite direction of the motion, right? Because if forward direction is positive, um, the force would be pointed in the opposite direction. And that's the reason why we're slowing down. Okay, question D. Where's the object moving at a constant speed? I don't love the question. How about when? When is the object moving at a constant speed? Well, constant speed just means that the points of our graph, since the y-axis is speed, are not moving up or down. And along this time interval, we have 15 and 15 and 15 and 15. And that means the speed is always 15. So this flat line is a constant speed. So that's a 10, 20 seconds. Calculate the distance traveled during 20-second period. We have to find the area under this graph for that whole interval. So let's break it into chunks that are easy. First 10 seconds is a triangle. Next 10 seconds is a rectangle. We're going to have a triangle and a rectangle and then a big triangle. So each one of these sections has their own area. We have a half base times height here. So that's 1/2 10 times 15. So that's, let's see, half of 150. So this is 75. This next one, base times height, which is, remember, the base is the length of the side. So 10 to 20, the base is 10, not 10 or 20. And the height is 15. So we're at 150. So we have another 150 here, same exact rectangle. Got the little triangle up top, base of 10, height of 10 for that. So we have 1/2 10 times 10, which is 50. Make sure I don't lose these areas. And then we have a large triangle here. So 1/2, my base is 20, and my height is 25. Okay, so half of 20 is 10. This is 250. All we have to do now, since they're all positive areas, we just add them together. 75 plus 150 plus 150 plus 50 plus 250. So let's see, that's 300 and another 300. That's 675. All right, so there's our displacement, 675 meters. Here we go. And said distance traveled. Um, so it's still 675 since we were always traveling in one direction. So just watch out, distance and displacement will be different. Distance, since we always traveled forward, right? We could go forward quickly, getting faster and faster. We could go slowly, we can slow down and then stop. All of that was forward travel. So that would be distance and displacement being the same. So this is a displacement. And if we ever had some forward and backwards motion, so let's say we travel forward 50 and backwards 25, the distance traveled would have been 75, but the displacement is always from start to finish. That would have been displacement of positive 25 meters. So just watch out distance and displacement, read carefully, and that will help you answer some questions.